All right, guys, here is example 2 for 10.2. Find the vertex, the focus, the directrix of each parabola, and graph it by hand. So it's going to be, I want to make sure that I am writing down all of the things they are looking for. So first, it wants us to find the vertex, find the focus, find the directrix, big D, and of each parabola, and then graph it by hand. All right, so these are all of the things that we are supposed to answer. So 2a, quantity y plus 2 squared equals -4 times x minus 3. Because your y variable is being square, so we know that it will either open to the right or the left, and this is negative, so we know for sure that it opens to the left. Okay. We have a few things we can find right away. First thing is we are going to find the vertex. The vertex is going to be your h comma k. So h is going to be 3 and your k is going to be -2. Next, we need to find an a value so that way we can locate the focus and the directrix. So a, it's going to be 4a, or -4a equals to -4. Or you can think of it as an absolute value of those. Since it's an absolute value, it comes out to be 4a equals to 4. A comes out to be a 1 unit. If it's 1 unit, we know that from the vertex to the focus is 1 unit, and from the vertex to the directrix is also 1 unit apart. So best thing for us to do right now is plot it out. Let me make some grids. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Vertex is at 3, up 3, -2. So 3 down 2, label it V. We know that it opened to the left, so the focus is going to be over here. I can find that location right away. That's 2, -2. The directrix is 1 unit, aka a unit. So here's directrix. X equals to 4. X equals to 4. Okay. If we know those three, we now need to find the total length of your lattice rectum. Length of, and it's always an absolute value for A. Absolute value for A happened to be an absolute value of 4, which is 4 units total. Okay, if I know it's 4 units total, I can go up 2 from the focus and down 2 from the focus to finish graphing by hand. And remember, I may ask you to find the location of the lattice rectum, so might as well get used to labeling these. This is 2, 0, and then this is going to be 2, 1, 2, 3, 4, -4. Okay, so those are them. We graphed it by hand, checked. We found the vertex, the focus, and the directrix of each parabola. Example 2b, very similar, except that we need to complete the square. Ready? To complete the square, we first will factor out the 2. We know the y variable is being square, so we know it either opened to the left or to the right. So y squared plus something, oh, I'm sorry, not plus something yet, plus 6y plus something blank equals -x plus 1. We do not need to complete the square for the x because we don't need to factor that out. Half of 6 is 3, 3 squared is 9. I'm going to add 9 over here, but that 9 is really being multiplied by 2, so this is really 9 times 2. This is now then factor out as a y plus 3 quantity square equals to -x. 1 plus 18 is really now 19 plus 19. And then we're going to get rid of this 2 in the front very soon. But before I do that, I want to factor out a -1. So that means I have x minus 19. To get rid of this 2 in the front, I'm going to multiply that by a half. What I do to that side, I do to this side. Here is our equation. Y plus 3 quantity squared equals negative 1/2 times x minus 19. This is our equation. Okay. Now I need to answer the parts that they want. Vertex, focus, and directrix. Here we go. Vertex, focus, and directrix. Vertex is always h comma k, so here's h and here's k, so that's going to be 19 comma negative 3. Ooh, okay, well, I'm definitely not going to do 19 take marks, so for the x location I will just do every 5 units. 5, 10, 15, extend this all the way out, 20, and 25. And the y-axis, I can stick it 1, 2, 3, 4, 5, 6, 7. Okay, so vertex is negative 19 comma 3. So it's right here. Eyeball 19. Sometime 19 comma negative 3. So here is your v. Next, I need to find an a value for us to even find the focus and the directrix. Are you ready? A value. Well, we know that it opens to the left because of the negative 1/2. See this right here? We are going to take negative 1/2. We're going to set it equal to negative 4a. To get rid of negative 4, we will multiply this by negative 1/4. Negative 1/4. So a will come out to be, ooh, super tiny, isn't it? A is 1/8. Oh my. So that means we are going to eyeball 1/8. So the focus, we know it opens left. So the focus is somewhere here on this left side and is going to be super close to the vertex. This is just 1/8. So what does that mean? I'm going to take the x coordinate of the vertex and minus 1/8. So the x coordinate of the vertex was 19. So 19 minus 1/8 comma negative 3 is the new order pair of the focus. Take away 1/8 is 18 and 7/8 comma negative 3. This is your focus. That gets filled in right here. 18 and 7/8 comma negative 3. And we're going to do the same thing to the directrix. The directrix is 1/8 behind the vertex. So that means it's going to be an x equals 19 plus 1/8, which is really 19 and 1/8. I'm going to try my best to graph out our directrix. I'm not going to hold you for this particular approximation. Okay, there you go. So that's going to be x equals 19 and 1/8. I need now to know find the length of the latus rectum, so I know how far up to go. Length of latus rectum, which is an absolute value of 4a, which we already know an absolute value of 1/2. Well, the total length is 1/2. That means you're going to go up 1/4 and down a 1/4. I'm going to see if I can fit 1/4 in here. 1/4 from, remember, you're going 1/4 from the focus. So here's 1/2, here's 1/4. I'm just going to eyeball this. This is going to be 1 skinny, okay, 1 skinny according to my grid. I went up 1/4 and I went down 1/4 from the focus as best as I can make 1/4. Then if I ask you to find the order pairs of the latus rectum, we can take the y value of the focus and we add 1/4, and we can also take the y value and we subtract 1/4. And remember, the reason we do 1/4 is because it's half of the total length. So if I ask you to find the latus rectum point on the top here, then we're going to take remember, the y value of the focus. So the x value should be exactly the same. The y value is -3, and we're going to add 1/4. Of course, we simplify. So 18 and 7/8, comma, -2 and 3/4 is the top piece of that. We could also do the same thing on the bottom. I'm using color. It's going to be x coordinate is the same, 18 and 7/8. And we're going to take the -3, which is the y coordinate of the focus, and we subtract 1/4. So this final answer for this bottom order pair for the lattice rectum is 18 and 7/8, comma, -3 and 1/4. So if I ask you for the order pairs, those are the 2 order pairs if it's ever asked. And that's how we find them. And I believe this is the end of example 2.